Hello friends, welcome to the series of lectures of Mathematics 1. Myself Hardik Patel from LJ Institute of Engineering and Technology. In today's session, we are going to start with the topic improper integrals. Now first of all, what is an improper integral? See, the integral of the form integration from a to b fx dx is said to be improper if both the limits a and b or either of the limit a and b is going to be infinite, or your function fx is going to be infinite at some point in between ab or at the end point of ab. Okay, that means if the limit is infinite or the function has a value infinite in between the given integral, then the definite integral is said to be a improper integral. Okay, now there are basically two types are there, and using them we are going to define third type. So first improper type 1 is if you have given the integral a to b fx dx, then it is said to be a improper of kind 1 if the lower limit or the upper limit or the both of the limits are infinite. That means we are going to write down in this form. Either it is from minus infinity to b 1 upon 1 plus x square dx, or it is from a to infinity 1 upon 4 plus x square dx, or it is from minus infinity to plus infinity 1 upon x square a square plus x square dx. See here lower limit is infinite, here upper limit is infinite, here both limits are infinite. Okay, so we have three conditions. First one, if the integration from a to t fx dx exists for every t greater than a, then the integration a to infinity fx dx is written in a form of limit t tends to infinity integration from a to t fx dx. Correct? That means whenever you have given any infinite limit, then this infinity will be replaced with some variable t, and this t is going to be tends to infinite. This is a first kind, and upper limit is infinite. Same manner, provided if this limit exists and is a finite number, then we are going to say that this improper is going to be the improper integral is going to be a convergent. Second part, if the limit is from t to b fx dx, where the function integration is defined for all t less than b, then your integration from minus infinity to b fx dx is written in a form of limit t tends to minus infinity, and infinity will be replaced with a t where t tends to minus infinity. Okay, so integration is written in this form, and provided that this limit exists and is a finite number. Okay, if the improper integral a to infinity fx dx and improper integration minus infinity to fx dx are convergent if the corresponding limit exists and both has a finite value. Okay, if the limit does not exist, then we are going to say it is divergent. Third case, if limit from minus infinity to a fx dx and a to infinity fx dx both are convergent, then we can define that integration from minus infinity to plus infinity fx dx is equal to integration from minus infinity to a fx dx plus integration from a to infinity fx dx. See, that means if you have given limit from minus to plus infinity, then first of all you have to break out your integration from any point a which is lies in between minus infinity to plus infinity, and then you have to evaluate both integrals separately. If the both integrals are convergent, then only your improper integration is said to be convergent. So please remember this thing, and you cannot write down this in a form of you limit t tends to infinity integration from minus t to plus t fx dx, because if you are going to find this limit and this value are not going to be same, you must have to divide it into the two integrals, separate integrals. Okay, now we are going with an example. Evaluate integration 0 to infinity 1 upon x square plus 1 dx. Now see here, function 1 upon x square plus 1 is continuous everywhere, correct, and your limit is infinite, so upper limit is infinite, so it is give improper kind 1. in improper integral of type 1, correct? So instead of infinity, we are going to put some variable t where t tends to infinity. So your integration is reducing in a form of limit t tends to infinity, limit integration from 0 to t 1 upon x square plus 1 dx. But integration of 1 upon x square plus 1 is nothing but it is a tan inverse x. So you have limit t tends to infinity, tan inverse x, limit is from 0 to t. Now put the limits. So first upper limit minus lower limit, that will give you limit t tends to infinity, tan inverse t minus tan inverse 0. Tan inverse 0 has a value 0. So you will have limit t tends to infinity tan inverse t. Now put the limit. So tan inverse infinity is nothing but it is pi by 2. So this is a finite answer, and since it is finite, so this integration is said to be convergent. And here we have given simple evaluation. So this is the answer of your integral. Same manner, second is determine whether the function integration from 1 to infinity 1 upon x square dx is convergent or divergent. Find the value if it is convergent. So we are starting with the integral. Since the limit is infinite and 1 upon x square is continuous everywhere in between 1 to infinity, so it is type 1 improper integral, correct? So what we are going to do is we are going to replace infinity by some variable t, and we are applying that limit t tends to infinity. So integration from 1 to t 1 upon x square dx, that will be written in the form of limit t tends to infinity, integration of 1 upon x square is minus 1 upon x, limit is from 1 to t. Substitute the limit, that will give limit t tends to infinity minus 1 by t plus 1, and if you are going to apply the limit, then 1 upon infinity will be 0. So your answer is 1. Correct? And since it is 1, so your given integral is going to be a convergent. Okay? So therefore the given integral is convergent, and its value is nothing but whatever the answer we get, that is the value of your integration. Now we are going to start with example. Evaluate integration minus 1 to minus infinity to 1 x e raised to 2x dx if possible. Now see, here you have x e raised to 2x is continuous everywhere, and the lower limit is minus infinity. So this is the improper integral of type 1. Now, so that's why we are going to replace minus infinity by some variable t, where t tends to infinity. So your integration is reducing in a form of limit t tends to infinity, integration from t to 1 x e raised to 2x dx. Correct? Now using integration by parts. So we are going to use the continuous integration by parts, that will give you x as it is e raised to 2x by 2 minus derivative of x is 1, and again integration of e raised to 2x, that will be e raised to 2x by 4, and then the derivative of 1 is 0. That's why we have terms up to this point. Now if you are going to substitute the upper and lower limits in this integral, then what you will have, limit t tends to minus infinity. First simplify this term, that will give x e raised to 2x by 2 minus e raised to 2x by 4. And now substitute the values. So upper limit is 1. So 1 into e raised to 2 by 2 minus e raised to 2 by 4 minus, if you are going to put t, then it will have a t e raised to minus 2t by 2 minus minus plus e raised to 2t by 4. And if you are going to apply the limit t tends to minus infinity, then e raised to minus infinity will be 0. And simplifying these terms, that will give you a final answer e raised to 2 by 4. So this answer is finite. That means your integral is convergent. And the answer of this integration is nothing but it is e square by 4. Okay. Now we are going with a example. Discuss the convergence of the integral minus infinity to plus infinity 1 upon 1 plus x square dx. Correct? So if you are going to integrate this one, then this is a improper of kind 1, type 1, correct? Because see, 1 upon 1 plus x square is everywhere continuous function. And both limits are now infinite. So lower limit is minus infinity, upper limit is of plus infinity. So we are going to break this integration from point 0. So we are writing this in the form of minus infinity to 0, 1 upon 1 plus x square dx, plus integration from 0 to infinity 1 upon 1 plus x square dx. So you have to find out these two integrals separately. Okay, so we are going to evaluate both integrations separately. So first we are going to evaluate the integration 0 to infinity 1 upon x square plus 1 dx. So instead of infinity, we are going to put variable t and applying limit t tends to infinity. So this integration is going to be integration of 1 upon 1 plus x square is nothing but it is tan inverse x. And you will have limit t tends to infinity tan inverse x 0 to t. If put the upper and lower limit, that will give you t tends to infinity tan inverse t minus tan inverse 0. And if you are going to put the values, then you will have limit tan inverse 0 as a value 0. So you will have limit t tends to infinity tan inverse t. If you are going to put infinite, then tan inverse infinity is nothing but it is pi by 2. So this is the answer of your second integration. Now we are going with a first integration, minus infinity to 0, 1 upon 1 plus x square dx. That means t tends to minus infinity, limit t tends to minus infinity, integration from t to 0, 1 upon 1 plus x square dx. Correct? Because minus infinity will be replaced with some variable t. So now you have again integration is tan inverse x. So you will have tan inverse limit t tends to minus infinite, tan inverse x for limit is from t to 0. So you will have limit t tends to minus infinity, tan inverse 0 minus tan inverse t. Tan inverse 0 as a value 0 and you have term minus of tan inverse t. Now if you are going to substitute minus infinite, then tan inverse of minus infinity is minus pi by 2. Correct? So you will have minus of minus pi by 2, that will be a plus pi by 2. So this is the answer of second integral. So if you are both integrals are convergent, therefore the original integral is convergent. And if you have to find the answer of it, then it is nothing but addition of both integrals. That means pi by 2 plus pi by 2. So this is the answer of original integration. Okay. So please remember this thing. Now, improper integral of type 2. Okay. Now in type 2, it is definite integral which integrand becomes infinite at a one or more points within or the end point of the interval of the integration. That means, suppose you have integration from 0 to 1, 1 upon x dx. Now this, see here limits are finite, but 1 upon x is not defined at 0 and 0 is in your interval integration, it is in a interval of integration. Okay, that's why you have to, this is the type 2 improper integral. Same manner here, plus or minus 1, x function is not defined at a plus or minus 1 and both points lies inside this. So here also you have type 2. Same manner here, this function is not defined at 4. So this is the thing which we are going to discuss it. Here limits are finite, but the function becomes infinite at either of the end point or any point in between the interval. So this is the type 2. So first we are starting with if fx is continuous on closed interval a to open interval b and it is discontinuous at a point b. Okay, then the integration from a to b fx dx will be written in a form of limit t tends to b minus, where integration is from a to t fx dx. Now see here why we have taken the left hand side limit, because your interval is ending on a or at a b. So we have only the left part of a b, right hand side is not there. Okay, so b a to b if you are going to consider, then b left part of b is in interval, right part is not there. But if you are writing simple limit t tends to b, then also it is okay. Then also the answer is going to be a same. Provided that this limit exists, then we are going to write it in this form and it must be finite. Same manner, instead of that, suppose fx is continuous on open interval a to close interval b and it is discontinuous at a point a, then the integration from a to b fx dx will be written in a form of limit t tends to a plus and a will be replaced by t. That means wherever your function is not defined, at that point you have to change it by variable. Okay, and the third, provided that this limit must exist and is a finite number. And the third case we have is nothing but fx is a discontinuity at any point c. Okay, in between this integration, that means your function is not continuous at a point c which is lies inside your interval. Then, and if both integration from a to c fx dx and c to b fx dx are convergent, then we define that integration from a to b fx dx is equal to integration from a to c fx dx plus c to b fx dx. That means you have to break it from the point where your function is discontinuous. Now we are starting with the evaluate. Example. So evaluate integration from 0 to 3, 1 upon under root of 9 minus x squared dx. Now see, if you are going to check out, then here the given function is improper integral of kind 2, type 2. Why? Because these limits are finite, but your function fx, that is 1 upon under root of 9 minus x square, is not defined at a 3. Correct? So it is not defined at a 3. So it is unbounded at a point x is equal to 3. And that's why your integration 0 to 3, 1 upon under root of 9 minus x square dx will be written in a form of limit t tends to 3, because 3 will be replaced with t. See, and as I have already told, we are not concerned with a left hand or right hand. So if you are going to write 3 minus or not, you are not going to write it, then also it is okay. So t tends to 3 and you have integration from 0 to t 1 upon under root of 9 minus x square dx. Now 1 upon under root of a square minus x square has an integration sine inverse x by a. So it is sine inverse x by 3 and limit is from 0 to t, where limit t tends to 3. Now put the upper limit and lower limit, that will give you limit t tends to 3 into the bracket sine inverse t by 3 minus sine inverse 0. But sine inverse 0 has a value 0. So you will have the sine inverse t by 3, and if you are going to put t is equal to 3, then sine inverse 1. Sine inverse 1 is nothing but it is a pi by 2. So you will have answer pi by 2. That means this is a finite value. So this improper integral is convergent. Same manner, find the value of integration from 2 to 3, 1 upon root of 3 minus x dx. So again, this is the type 2 improper integral, and fx is not continuous at a 3. So upper limit is 3, where your function is not integrable. So if you are going to put the value, then 3 will be replaced with t, where t tends to 3 minus. Okay, and integration from 2 to t 1 upon root of 3 minus x dx. So the integration of 1 upon root will be nothing but it is minus 2 under root of 3 minus x, and limit is from 2 to t. Here we are using the integration of a minus x raised to n. Okay, so a minus x raised to n has an integration a minus x raised to n plus 1 upon n plus 1 into minus 1. And if you are going to put the upper limit and lower limit, then you will have that 2 into under root of minus 2 into under root of 3 minus t plus 2. Now put the limit t tends to 3, then that will going to be 0. So this term is going to be 0. So your answer is 2. Okay. So this is the finite value. So this integration is convergent. Okay. And its value is nothing but it is 2. Now test the convergence of integration from minus pi by 2 to plus pi sec x dx. So what we have done is going to put the values. Sec x is not defined at pi by 2, correct? Because sec pi by 2 is infinite. So what we are going to do is, instead of pi by 2, we are going to put something t, and that t tends to pi by 2 plus. Now integration of sec, that will be a log mod sec plus 10. And if you are going to put the values, then upper limit minus lower limit. So sec pi has a value minus 1, 10 pi has a value 0, correct? So minus 1, but here we have a mode. That's why if you are going to substitute the value, then you will have log 1 minus log of sec t plus 10t. Now if you are going to put the limit t tends to pi by 2, then pi by 2 plus, then sec pi by 2 plus is minus infinity, same manner 10 pi by 2 plus is minus infinity. So minus infinity, that is minus infinite. And mode is taken, so log of mode infinity, that will be infinity. And here minus is there, so the answer is minus infinite. And since the answer is minus infinite, that means this integration is not going to be a convergent. And that's why this integration is not convergent, so it is divergent. Okay. Now we are going with the example, evaluate integration from 0 to 3, 1 upon x minus 1 dx if possible. So first of all, this function is not defined at 1. and 1 is in between your integration. So in between your interval of integration. So function is not defined at 1. So that's why we are going to break this integration from 1. So you have integration 0 to 3, 1 upon x minus 1 dx. That will be a integration 0 to 1, 1 upon x minus 1 dx, plus integration from 1 to 3, 1 upon x minus 1 dx. Now, first we are going to find the first integral, and that will be integration from 0 to 1, 1 upon x minus 1 dx. Here function is not defined at 1. So we are going to use the simple property, replace 1 by t, and that t tends to 1 minus. So integration of 1 upon 1 minus x, that will be a log. So integration will be a log mod x minus 1, and limit is from 0 to t. Now put the limit, that will give you log of mod of t minus 1 minus log of mod of minus 1. Correct? Now log of 1, mod of minus 1, that will be 1. So log of 1 is 0. So that will give you limit t tends to minus 1, 1 minus t. Now put the limit. So you will have 1 minus 1, 0. And 1 minus 1 is 0. That means log 0 is going to be minus infinity. So the first integration is infinite. That means it is divergent. So we are not concerned with second. Second is going to be divergent or convergent. In either case, your integration, original integration is going to be a divergent because the first integral is divergent. So this integration 0 to 3, 1 upon x minus 1 dx is also going to be divergent. Now see, please remember, if you are directly integrating this term, then in that case you are going to write this in the form of log of mod of x minus 1, and limit is from 0 to 3. Now put the limit, that will give log of 3 minus 1, that will be 2, minus 0, then you will have log mod minus 1, that will be 1. So your answer is going to be a log 2. And you are going to say that this integration is convergent. But it is not in factly convergent. It is divergent that we have shown here. So this type of integrations are called improper, and in that case you must have to use the improper integration. Okay. So this is not possible to integrate. So remember this thing. Direct integration is not going to be applicable here. Now, these are the topics which we have covered in today's session. If you have any doubt or any query regarding these topics, then please feel free to contact me. Thank you so much.